So good afternoon, ladies and gentlemen. And I'd just like to say, first of all, big thank you to NTNU, Senses, and Statoil for inviting me to speak this afternoon. I'm speaking on behalf of the downstream petroleum refining industry of Europe. Fuels Europe has represented that industry to the European institutions now for 25 years, formerly known as Europire. And we'll talk this afternoon about electrification and how we think about this. We're often asked questions like, surely this is the future, why are you not investing in this? How do we think about this? How do we make it work in policy? So I'm going to play back to you some of the thoughts that we've got about how we look at this. I'll speak personally as well. I'm a mechanical engineer, so I tend to focus on the physical things that we need to make work, and then think about how do we make it work in policy. So I'd like to reflect on some of the things that we've observed about this, and then we'll talk about what does it mean for policy, and also the choices about the right technologies to support. I'm given 17 minutes, and I've got a timer down here. I'm down to 16 already. I've got quite a lot of slides to get through, and I'll cover these key points as we go through here. First of all, about Fuels Europe, only a few seconds. Fuels Europe has 40 members, including probably every petrol station brand that you know, and amongst these, several of these companies have already invested quite heavily in renewables. But when it comes to transport, the options are a little bit more confusing and more difficult to understand, and we'll talk about some of those as we go through. The value chain that we represent here is everything from transport of the crude to the refining, transport of the products and the marketing of the products, the downstream industry. And I'd really like to focus in particular around what we see are the drivers of electrification today, and to think through what does that mean for vehicle regulation. Why do we focus on vehicle regulation? Because actually vehicle regulation determines tomorrow's energy mix. And tomorrow's energy mix is actually chosen by today's regulation. Some of you may know that the European Commission actually has a consultation open right now and a process for developing the next wave of vehicle regulation for Europe. So we need the best regulation for vehicles today to determine the energy mix for tomorrow. And this is our view of what are the key drivers for electrification for light transport right now. It's around CO2, and there the stakeholders are governments, the policy that governments brings forward, concerned citizens and NGOs, of course. Air quality, a similar group of stakeholders pushing this quite rightly so. We do have an urban air quality problem in Europe, and it's certain that road transport currently contributes to that quite significantly. So we do need to understand it better and do something about it. Lower costs for drivers. Right now, many of the early adopters of electrification are attracted by the fact that the marginal cost for each kilometer is near zero, and that's certainly an attractive proposition. Electricity is no doubt cheaper than petrol or diesel. Lastly, we have this proposition that electrification is actually an industrial opportunity for Europe, and we think that's worth a look as well. So, CO2 emissions. Now, I'm going to make reference here to some data that actually NTNU have put together, and we've incorporated this into a way of looking at how vehicle regulation is working today and how we think maybe it should work in the future. Now, if we look at the cumulative emissions of a vehicle, the choice of a vehicle, an efficient internal combustion engine vehicle compared with a similarly sized electric vehicle, we've chosen a Nissan Leaf versus a Mercedes A-Class. And we look at how does vehicle regulation treat this vehicle today. This purple line at the bottom represents the cumulative emissions of the vehicle over 150,000 kilometers. And the vertical axis here, cumulative emissions in tons, simply in tons total. So the Nissan Leaf today, treated in vehicle regulation, it's a zero emission vehicle. And the Mercedes A-Class here, I think this is 139 grams per kilometer, so it's actually not the best available technology today. 139 grams there describes the slope of that line, so you accumulate emissions up to around 28 tons over the life of the vehicle. Actually, this is adjusted for real driving emissions and for the well-to-wheels, and actually that number is about 184 grams. But actually, we know that the life cycle of the vehicle, if you look at the manufacturing and the recycling of the vehicle overall, brings in a different angle, and of course, the life cycle of the energy. So, if we were to look at the Nissan Leaf, incorporating the manufacturing of the vehicle and the battery, we actually start out with 13.5 tons. And of course, if you then factor in average European electricity carbon intensity, you get a slope on the line as well. Of course, you should treat the Mercedes in the same way. And if you do that, you get 7.5 tons in manufacture. And the Mercedes is still a higher emission vehicle. But actually, the difference is much smaller than you might think. It's the order of 20%. And just so you know, that's a vehicle with a 24 to 30 kilowatt hour battery. And there's the numbers for the Mercedes there. The proposition for electricity actually requires probably a greater range than the Nissan Leaf, which would mean a bigger battery, which would maybe move that data point up. Of course, the slope of the blue line will probably come down in time because we reduce the carbon intensity of the electricity. But the slope of the line for the Mercedes can also come down because we can improve the vehicle, and there may be things we can do with the fuel as well. And if we improve the carbon intensity of the fuel, you'll reduce the slope of the green line. The key point is there's a technology race going on there, but we're focusing only on one solution and putting huge support into one solution and not the others. And I would suggest that we should think about how do we close that gap, and can we close that gap cheaper than we do electrification to start with. So I've made some of these conclusions already, and in the interest of time, I'm going to move on to show that there are already many valid views, this is from MIT, that there is still significant potential to improve the internal combustion engine. And actually this set of graphs is rather a complex set to go through, but shows that a plug-in hybrid or a hybrid electric vehicle actually can be quite competitive with an electric vehicle looked over the well to wheels, even without the manufacturing issues, probably in 2030 and 2050. And so we believe there's still value in pursuing the research and development of the internal combustion engine, as well as of the liquid fuel. Now, we've made the point on a number of occasions in Brussels that electrification looks expensive. And I'll show some numbers shortly. Part of the response is that, of course, electrification also brings you urban air quality improvements. We would agree, and those are valuable. But there's also the question about, is it the only way to achieve those? We have paid for some work and done some modeling of vehicle emissions and the development from Euro 2, 3, 4, 5, and Euro 6 level emission standards, and looked at what is the effect of fleet turnover on urban air quality in our cities. In the interests of time, I'm going to skip through this slide, which focuses on particulate matter, which shows the story of development of particulate matter, and I'm going to go on to NOx, and recognizing that so far, in the early days of the Euro standards, the NOx of performance of vehicles has not been good enough. The Volkswagen scandal underlined that very clearly and brought that strongly to people's attention. The modeling that we've done shows actually, on this graph here, the percentage of European population that is living in areas that are compliant with air quality standards. The green, right, the top of the graph is 100%, the green sector there. On the left-hand side, 1990, progressing to 2030, showing that the green sector is growing, the percentage of the population that lives entirely in areas compliant with air quality standards. That progression is almost entirely driven by fleet turnover. And in fact, the lines at the bottom that we've added on the graph here, I'm going to zoom in on this here, show what is the difference between a full electrification scenario and a scenario with full turnover to Euro 6 internal combustion engine vehicles. And you'll see that the difference is quite small. It's not a zero difference, but we do say that there are other things you could do to address that. The simple point is, yes, we must address urban air quality, but we're already quite a long way there by introducing Euro 6 vehicles into the mix. We must now robustly implement that across our cities, and it will make a very big difference across Europe. So we've already got a lot of the solution in hand. Now, I'm sorry, I've skipped over some of these points in the interests of time. Costs for drivers. We should not forget that most of the fuel cost today is actually tax. Actually, if you described that as a carbon tax, we'd be putting a carbon tax on at about 300 euros a ton. We don't describe it as a carbon tax, it's a revenue-raising tax. but that's the biggest component of the energy cost today. This is a calculation that we've done, that we've shown repeatedly, to show how would you come up with a cost of carbon for electrification in light transport. And the left-hand side is actually just the study of the well-to-wheels numbers for the carbon intensity. Battery electric vehicle on an EU mix of electricity today is around 57 grams per kilometer, whereas a diesel vehicle running what we call B7, 7% biodiesel fuel standard in Europe, about 101 grams. The table on the right-hand side here is a rough summary of the costs in policy of getting to that decision to switch from an ICE vehicle to a battery vehicle. We see already car manufacturers are describing a cross-subsidy in their range around 4,000 euros a ton. Financial Times analysis of Tesla accounts suggested it could be as much as 14,000, the loss per vehicle. But it is undoubtedly a loss per vehicle that car makers make. Government purchase grants in most European countries around 5,000 euros. Loss of fuel excise duties around 5,000 euros. There are some fuel savings. We should add those back in. So we estimate roughly 10,000 euros of policy costs, cost to society, to make the switch for the foreseeable future. And by the way, there are increasing calls for incentives for electrification, in particular from German manufacturers and some of the NGOs. You do the calculation, that saving of 44 grams per kilometer over 200,000 kilometers, you save 8.8 tons over the life of the vehicle. So you can do the maths, it's there, 1,100 euros per ton of CO2. That's ignoring the manufacturing issues as well. It's an extreme cost of carbon. It really is. It's kind of a luxury solution for how do we get to decarbonize. I don't think we can meet the Paris commitments by spending 1,100 euros a ton in Europe to get decarbonization. We need to think about how we can be more cost effective. Costs for the taxpayer, I will allow you can find these slides later and go through the maths here, but I'll just help you. If we were to turn over the whole European fleet, putting in 10,000 euros per car, we would spend, well, you can see, trillions of euros actually to turn over the European fleet to electrification. We need to find a way of getting lower cost decarbonization to meet our targets. Industrial opportunities for the EU. We should remember that Europe is today a leader in the internal combustion engine, in the efficient vehicles, especially diesels. And in fact, we do have diesels that fully meet the air quality limits today. Euro 6, the very latest, they do meet. In terms of battery production, I will show you a graph taken from the Financial Times yesterday, actually, in terms of the production of lithium-ion batteries set to be in place by 2020. And I don't know whether you can read the players there. Right at the top, one factory in China, and then the Tesla Gigafactory in the US. Almost all of the rest is China, South Korea. There is one small facility in Poland. There is nothing else in Europe. We have to ask, is this an industrial opportunity for Europe? We're a long way behind. Impact on oil demand. This is a short extract from BP Energy Outlook. I will just draw your attention to one graph at the end here in the interests of time, showing that the outlook for 2035, showing the difference between oil demand on the left of this graph and 2035 oil demand on the right-hand side. You see that there's a growth projected for demand in travel. There are some significant gains in fuel efficiency. Switching to natural gas vehicles is part of the answer, but a very small one. Switching to electric vehicles is projected to be mostly in OECD countries like Europe. And then you're left with some significant demand still for petroleum. The conclusion that I would reach, or I'd suggest from this, is that there is still potential for efficiency in vehicles to make a very big difference globally. And that given we've got a lead in this technology, we should think about how do we support efficiency improvements. We should also think about what else we can do around the liquid fuel. We know that there are several sectors, aviation, marine, heavy duty, construction, agriculture, that will likely need liquid fuels for decades to come. So rather than focusing on one narrow technology in one sector of overall transport, our suggestion is that we broaden our support and are more even in the way we support all the new technologies to make a difference across a wide range of different sectors in transport. And so some conclusions: the current drivers for EVs, life cycle analysis for CO2 actually shows that these vehicles are not zero-emission vehicles. They're essentially a mechanism of displacing the emissions, in some cases outside of Europe and outside of any carbon policy. Air quality, we can and we should meet air quality standards, and we can do that substantially with a full turnover to Euro 6 vehicles with the new drive cycle, with real driving emissions measures, and a robust implementation. Lower costs for drivers, actually that's mostly a taxation effect. Industrial opportunity, it seems like we could be on the verge of giving up an industrial advantage we have today for something that is not going to be an advantage for us. So I do believe we should pause, and we're going to have exactly this conversation with the European institutions about how do we rebalance and adjust vehicle policy to take into consideration a wider range of technologies. I will not go through this in detail. I'm just inside the time. Happy to have questions later and be part of the discussion. Thank you.